Hey Chem Kids, Campbell here. In our second video in Chapter 17, we're going to talk about LeChatelier's principle. Cool. What LeChatelier's principle says is that if a system is in equilibrium, so I no longer have my concentrations changing, my rates are the same, if I subject it to a stress, then the reaction is going to shift in the direction to relieve the stress. See, even reactions don't like stress. So if we give it stress, it's going to do whatever it can to get out of that stress and get back into equilibrium, get back into balance. Now, what could stress out a reaction? I mean, chem tests and those lab quizzes certainly stress us out. But for a reaction, things that stress it out are changing the concentration, either of a product or a reactant. That would get it all out of equilibrium. Changing the pressure for gases, that definitely has an effect on the stress of the reaction. And also changing the temperature. Remember in our first video I said that temperature will affect the KEQ. So not only does it affect the value of the equilibrium constant, but it also gives the reaction some stress. Well, let's see what happens. So if we think about this stressful situation, can't figure out where to put myself. There we go. It's like a teeter-totter of reactants and products. And if I add more reactants, so if I add more stuff to the left side of this, my reaction gets out of balance, and I'm not balanced anymore. So what happens is the reaction will want to restore balance. It wants to be all leveled out here. So in order to do that, it's got to produce more of this, right? This has to be heavier so it can get back in balance. So LeChatelier's principle is all about keeping a balance and restoring that balance if somebody stresses it out. So let's look at stressing out reactions. First, let's look at changing concentration. All right, so a reaction, we say a reaction shifts in the forward direction. That means reactants are going to products. That's the forward direction. That'll happen if we add more reactant or remove product. So if we think about what happens if we add more reactant, right, it's like this side of the teeter-totter got heavier because I added more reactant. So I'm out of balance. So what the reaction's going to do, it's going to shift in the forward direction and start using up some of those reactants to make products. And if I do that, right, if I use up some of the reactants and I make products, this side gets lighter while this side gets heavier, and I get back into balance. Another way that this could happen, that the reaction would shift in the forward direction so I make more products, is if I remove some of the products. Right? If I remove some of the products, then this side of the teeter-totter is getting lighter. This side of the reaction is lighter. And so the reactant's like, hey, give me some of that back, man. So what does it got to do? Well, it's got to make some back. So it takes some of those reactants and makes them products. And as I use up reactants and I make products, I get back into balance. So a reaction shifts in the forward direction from reactants to products if I remove some product or if I put in some reactant. So it wants to use up the extra that I put in or make more of what I took away. Now a reaction will shift in the reverse direction, so products reforming reactants if I do the opposite. So if I add more product, I don't know why I would do that, but if I add more product, right, this side's heavier, so it's going to want to use up some of those reactants, get rid of that extra stuff I put in, and go back to reactants. So I get back in balance. Or if I remove reactants, right, if I take some of the reactants out, it's going to have to get rid of some of these products and make more reactants to get back into balance. So the reaction shifts in a direction to relieve the stress. If I add more of something, it's going to want to use it up. So the reaction shifts away from it. Or if I take something away, then it shifts to replace it. So it shifts in the direction to replace what I stole. So let's look at an example of this. This again is my Haber process. Nitrogen gas plus hydrogen gas produces ammonia. What happens to the concentration of my ammonia, my product, and my hydrogen, a reactant, if I add some nitrogen? So what I'm doing is I'm adding more of the nitrogen gas, which means I have more reactants now. I'm out of balance. So what's going to happen? What do you think? Well, I added reactant, right, which means the reaction is going to shift in the forward direction. So I'm going to produce more product so I can get into balance. But in the process of doing that, in the process of moving forwards to produce more product, I have to use up some of the hydrogen, right? I know I didn't add more hydrogen, but in order to make more nitrogen or more ammonia, to use up that nitrogen I added, I'm going to have to use up some hydrogen. So I'm going to produce more NH3, and in the process, I'm going to use up some of that hydrogen. So the concentration of NH3 will go up so I can get back into balance, and some of my hydrogen will be used up, so it's going to go down. So which way does my equilibrium shift? Well, it shifts in the forward direction, to the right. So when you're solving problems for LeChatelier, when I ask you these questions, I'm going to be asking you what happens to the concentration of the various substances, reactants, or products, and then which way does it shift? Forward direction, which would be right, or the reverse direction, which would be left. All right, let's take a look at another thing. Let's look at temperature, right? Temperature is another thing that can stress out a reaction. So we treat these changes like heat is a reactant or a product. If you remember chapter 15, we talked about endothermic and exothermic reactions. And endothermic reactions are reactions that need energy, need to absorb heat in order to go from reactants to products. So we say that heat is like a reactant. We need to take heat into the reaction in order to form products. But in an exothermic reaction, heat is released, right? It gets warmer. So heat is a product in that reaction. So we're going to treat heat as if it was a reactant or product, and we're just changing its concentration. So, for example, here is that reaction 2 nitrogen dioxide produce dinitrogen tetraoxide. This reaction is an exothermic reaction because heat is a product. Therefore, if I add heat, right, it's as if I'm adding a product. So if I increase the temperature of this reaction, I have now increased my product, heat, which means the reaction is going to shift in the reverse direction, which is to the left, to restore balance. Or if I cool it down, right, if I cool it down, it's like I'm removing heat, because I'm removing a product, then the reaction is going to shift to replace the heat that I took away. So the reaction proceeds in the forward direction, which is to the right. So we're going to treat heat like a reactant if it's an endothermic reaction, or like a product if it is an exothermic reaction. So whatever I add, the reaction shifts to get rid of it. Or if I take it away, the reaction shifts to replace it. Now remember that changing the temperature also affects my KEQ value. So I don't restore the original equilibrium. It's going to shift a little bit. What about changes in pressure? Now, pressure is only going to affect gases. Gases are the only thing that we can affect with pressure. Now, what's interesting about pressure is that, remember that pressure is created by collisions of molecules. So the more molecules I have, the more pressure they create. So if I increase the pressure in a reaction, it's going to shift in the direction that produces fewer molecules. So in this reaction, I have 2 molecules of NO2, and I have 1 molecule of N2O. So if I increase the pressure in this reaction, it's going to shift in the forward direction. It's going to combine 2 molecules and make 1. Then I have less collisions because I have less molecules, and it will reduce the pressure. So if I increase the pressure, it shifts in the forward direction to reduce the number of molecules. If I decrease the pressure, then it wants to replace that pressure. It wants that pressure back. How does it do that? It makes more molecules. And the way it would do that is it would shift to the left. So I have 1 molecule here and 2 here. So I'm going to shift in the direction to make more molecules. So when you are doing these changes, look at the change. For pressure, actually count the molecules on each side of our reaction. Whichever side has more molecules, that's the side that if we decrease pressure, it's going to shift to, because we want more molecules for more collisions. But if I increase the pressure, it wants to get rid of those collisions. It wants to reduce the pressure, so it shifts in the direction of fewer molecules. Wow. All right, let's try a couple of problems here. Here is our Haber process again. Haber process is actually an exothermic reaction. How could I maximize the production of ammonia? This is very economically important. What are some of the things I could do? Pause the video and think about it. Maybe write it down. Well, how could we change the pressure? Well, let's count molecules. If we have 3 hydrogen and 1 nitrogen here, I have a total of 4 molecules on this side, and I only have 2 molecules on this side. We don't count heat as a molecule. So if I want to increase the ammonia, then I want to shift the direction to the right. So I want to shift the direction with fewer molecules. So that means I need to increase the pressure, right? If I increase the pressure, I'm going to shift in the direction to produce fewer molecules. So shift to the right. What about temperature? If I want to produce ammonia, then I want to reduce the temperature, right? I want to pull heat out of the reaction because it's going to shift then to replace the heat. So if I cool the reaction, I decrease temperature, the reaction is going to shift to the right. So far I have an increase in pressure and a decrease in temperature. What else could I do? What about the effect of concentration? Well, we could remove ammonia, right? If I remove this ammonia, right, it makes this side lighter. So that means I'm going to produce more ammonia. So if I can just pull the ammonia out, the reaction is going to keep running to replace it. Or I could just add more reactant, right? The more reactant I add, right, the heavier this side gets, the more I'm going to make product to get back into balance. So increase pressure, decrease temperature, remove ammonia, or add more nitrogen or hydrogen. So make sure that you know that LeChatelier's principle says that a reaction shifts to undue stress. So look at what the stress is and then figure out how do I get rid of it. If I add a substance, it's going to move in the direction to get rid of that substance. If I remove a substance, it's going to shift in the direction to replace it. Treat heat and temperature. Treat it as a product or a reactant. And then for pressure, look to see which side, how the molecules relate. As I increase pressure, I'm going to shift to the lower molecules. As I decrease pressure, I'm going to shift to the side with a higher number of molecules. All right, fill in the turn-in sheet, write me a summary, and ask me a question. You probably have quite a few, and I'll see you in class.